Batteries play numerous important roles in everyday life, from providing the initial power needed to start the engines of cars to acting as a backup source of electricity in telecommunications, public transportation, and medical procedures. Batteries also have the potential to help reduce greenhouse gas emissions by efficiently storing electricity generated from both conventional and renewable energy sources, and as a source of power for electric vehicles. Batteries power everything, from mobile phones to laptops, drones to electric cars. Batteries have also taken to the sky as several companies are working on battery-powered electric aircraft. However, the current lithium-ion batteries have several limitations that affect their applications in many practical ways. For example, it lasts only 2 to 3 years after manufacture. It is sensitive to high temperatures. If the battery is completely discharged, it can no longer be recharged again. It is relatively expensive, and if the separator gets damaged, it can burst into flames. The high temperature that develops during battery operation, high cost of production, and issues related to recycling of dead batteries are the major disadvantages of lithium-ion batteries. Thus, the focus has shifted to graphene batteries as energy storage systems for EVs in recent years. Welcome to another Electric World video featuring the latest news about Elon Musk, Tesla, and SpaceX. This time we would be discussing the latest news about a new game-changer graphene-based battery. Before we get started, make sure to subscribe to this channel and turn on the notification bell. It helps you get notified when we post more content just like this. Let's get started. Since its isolation in 2004 in its freestanding form, graphene has sparked tremendous attention and the huge range of exceptional and desirable electrochemical characteristics, which has made it one of the most promising candidates for use in energy storage applications. A group of researchers has developed a new graphene battery that promises huge improvements. Who are these scientists, and how does their graphene battery work? Prior to the introduction of lithium-ion batteries, electric vehicles had very limited driving ranges and long charging times. Lithium-ion batteries, on the other hand, have enabled vehicles to have longer ranges and faster charging times. This isn't to say that lithium-ion batteries are without drawbacks. Despite the fact that they offer improvements, they are still heavy. In fact, they make electric vehicles heavier than vehicles powered by internal combustion engines. They still take a long time to charge and are quite expensive, making EVs out of reach for many people. Electrolytes in liquid or gel form are flammable and may freeze, requiring expensive warming, cooling, and safety monitoring. Fast charging may also cause lithium metal spikes to pierce the battery's permeable separator, causing the cell to short circuit. While solid-state batteries provide several advantages, one disadvantage is that lithium formation on the anode causes the cell to physically expand, which must be taken into consideration when designing the pack. They are extremely expensive to make, and multiple companies are trying to lower the price in order to be the first to market with them. One area of battery research that has been generating a buzz is graphene-based battery. It has been lauded as the next frontier in battery development and will solve many lithium-ion battery problems. So, what is graphene exactly? Graphene is a crystalline allotrope of carbon with two-dimensional properties. Graphene is very thin and nearly transparent and is a single layer of graphite. It is remarkably strong at 200 times stronger than steel and conducts heat and electricity with great efficiency. Apart from that, graphene is an excellent conductor of heat and electricity, and has interesting light absorption abilities. Graphene is 1,000,000 times thinner than a single human hair, and it is so thin that it is classified as two-dimensional. Carbon atoms are densely packed in a regular chicken wire pattern in graphene. It is so strong it would take an elephant, balanced on a pencil, to break through a sheet of graphene the thickness of saran wrap. According to Columbia University, graphene has the ability to revolutionize the world since it is a material with limitless potential in practically every sector. Graphene is a diverse material that may be mixed with a variety of other elements to create a variety of compounds with improved qualities. Graphene is a good conductor. Electrons travel through it more easily than they do through copper. The electrons move across the graphene sheet as though they had no mass and as fast as 1/100th of the speed of light. Graphene is 7 times harder than diamond and almost 200 times harder than steel. To put this into perspective, it will take the weight of an elephant balanced on a needlepoint in order to break this 1-atom-thick fabric. The tensile strength of graphene exceeds 1 TPa. Even though graphene is so strong, it is also very stretchable. You can stretch graphene up to 20% of its initial length. Researchers all across the world continue to study and patent graphene in order to understand more about its properties and its benefits, which include transistors, computer chips, supercapacitors, and even DNA sequencing, water filters, antennas, touchscreens for LCD or OLED displays, and solar cells all benefit from graphene. Graphene is extremely useful, and scientists are discovering new uses for it on a daily basis. Producing high-quality materials, on the other hand, remains a difficulty. Graphene materials are now being manufactured in considerable quantities by dozens of companies around the world, ranging from high-quality single-layer graphene synthesized using a CVD-based technique to graphene flakes made from graphite. High-end graphene sheets are mostly employed in R&D or in extreme applications like sensors, while graphene flakes, which are manufactured in huge amounts and at cheaper costs, are used in a variety of applications including sports equipment, electronic goods, automobiles, and more. However, one of the most exciting areas of graphene research and development is batteries. Graphene has attracted the attention of battery manufacturers for a variety of reasons, including its potential use in electric cars. To develop their batteries, they seek to take advantage of the high porosity, larger surface area, extreme strength, and low weight. Furthermore, these materials have a high charging capacity and flexibility, as well as being strong thermal and electrical conductors, making them an ideal material for energy storage. Because graphene has a high electrical conductivity, it enhances electrode density and speeds up the chemical process inside the battery, allowing for more power transmission and quicker charge speeds while producing less heat. Graphene also degrades less than lithium while giving better performance, extending the life of electric vehicle batteries significantly. Graphene batteries are also more cost-effective and long-lasting than other EV batteries. Graphene lithium-ion batteries are the most likely to be deployed among the several graphene-based battery technologies and types. By the next 4 to 8 years, solid-state graphene batteries might be available, and graphene supercapacitors within 10 years. Lithium-ion batteries may be replaced by graphene sodium-ion and graphene aluminum-ion batteries. Sodium and aluminum are significantly cheaper and simpler to recycle than lithium, because they are more abundant in nature. Graphene aluminum-ion batteries may one day replace lithium-ion batteries as the primary EV battery, since graphene aluminum cells charge 60 times quicker and hold significantly more energy than pure aluminum cells. Graphene aluminum-ion cells, for example, can recharge an AA battery in under a minute and a coin cell battery in under 10 seconds. Los Angeles startup Nanotech Energy claims to have found a fireproof, graphene-based lithium-ion battery. And if this battery can do what it's promised, we're talking about a true game changer. Nanotech has found a way to eliminate the safety concerns of batteries once and for all with a fireproof, graphene-based lithium-ion battery. This is huge as it is a true game changer in the battery industry. Nanotech has developed graphene electrodes, namely, the battery's positive and negative terminal. According to the company, graphene's flexibility means that it can withstand the volume changes of the battery electrodes during charge and discharge. This reduces the chances of an internal short circuit, which can potentially lead to fire. What's more, graphene is an excellent conductor of electricity, which helps the battery maintain a lower internal resistance. Simply, the ability to maintain a lower internal temperature. As a result, it provides an efficient solution to overheating during charging, which is another potential cause of fire. The electrolyte is a vital part of a lithium-ion battery, as it transfers lithium ions between the two electrodes during charge and discharge. But it's the battery's most flammable component. Most electrolytes in use today involve dissolving a lithium salt in a liquid material composed primarily of linear and cyclic chain carbonates. Basically, molecules that involve a carbon atom attached to 3 oxygen atoms. These liquids are typically flammable and can be volatile and unstable when exposed to high temperatures. Nanotech has developed a proprietary electrolyte solution called organolyte that is stable, made from inexpensive materials, easy to manufacture, and, of course, is non-flammable. While no specifics have been disclosed, the name suggests the material still centers around organic chemistry. What have the tests shown? Nanotech has run a series of tests to demonstrate that its graphene organolyte battery shows enhanced thermal stability and eliminates the risk of fire. In both, the standard lithium-ion battery used instantly catches fire, while the graphene battery remains unharmed. A new super battery. The battery performs well in a wide range of temperatures, keeps a charge at temperatures as high as 176 degrees, and does not catch fire when penetrated with a nail or heated to more than 704 degrees. But Nanotech goes even farther, claiming that their battery is highly powerful. It can charge 18 times faster than anything that is currently available on the market and maintains more than 80% of its rated capacity after 1,400 cycles. Furthermore, the company's new batteries may be fully customized to match any form factor or container and can be used in consumer electronics, electric automobiles, and other electrified devices. That's probably why Nanotech's batteries earned the CES Innovation Award in 2022. When will the tech be available? Nanotech's non-flammable lithium-ion batteries will be produced in a newly announced production plant in Nevada, which is expected to open in the fourth quarter of 2022. Initial manufacturing would likely concentrate on the consumer electronics industry, since the battery's application in vehicle industries would need additional durability, dependability, and safety testing. This might take a few more years, and I'm excited to see the battery in action. Let's hear what you think of graphene batteries in the comments section below. And thanks for watching the video. If you want to continue to learn about everything regarding Elon Musk's plans in Tesla or electric vehicles, we've got 2 more video options for you on the screen to check out. And don't forget to give a thumbs up on this video if you liked it and subscribe to our Electric World channel for daily content just like this.